Hello everyone, welcome back. So in this video, we are going to continue to talk about 2.3 shell method, cylindrical shell method. So if you remember in chapter 2, we've been introducing 3 different methods, slicing method, disc method, washer method, and shell method so far. So let's take a look at what the shell method look like. And each method has a different characteristic to measure the volume. So let me just go to down here quickly. So the one of the characteristic of utilizing cylindrical shell method, you are going to have a many infinite number of the cylinder so that you are adding all the cylinders and then you can find out the volume of the solid shape, right? So let's write down the formula of the cylindrical shell method. So that is a V equal to 2 pi RH, so 2 pi A to B. If you rotate the function about y-axis, we talk about that, you're gonna have the perpendicular variable. So x is a radius, and then all the variable is in terms of the x, and this is what you rotate the function about y-axis. And then another one was 2 pi when you rotate the function about x-axis, but in this time y, hy dy, this is the dy when you rotate the function x-axis. So the x is the radius of the cylinder and this is the height. And then if you rotate y-axis, it's opposite dx. If you rotate x-axis, you're gonna have opposite variable dy. This is the same radius and this is the height. So we talked about this function, right? So let's take a look at the example. It's a little bit complicated, but I will show you why we're gonna keep utilizing shell method. So in this example, I have a region, and then this is going to be, under the curve y equal to x, and then below the, below and above the x-axis from 1 to 2, and then we are going to find the volume of this solid shape when you're rotated about x equal to -1. So hold on. We are going to revolve this function about x equal to -1. So I will say this is not simply rotating about x-axis or y-axis. What I'm saying is we used to rotate the function. If you watch the previous video, we rotate exactly the function on the x-axis or on the y-axis. But in this question, what they're saying is you are going to rotate this function around x equal to -1 right there. So we are going to rotate this function where x equal to -1. So which is not exactly y-axis or x-axis. So because of this reason, right, the radius of the cylinder also shift, okay? So they say the radius of the shell is going to be x plus 1. So we used to have, if you rotate exactly the function about y-axis or x-axis, the radius has been fixed, either x and y, right? So if you rotate the function about the y-axis, you have a many infinite. The radius was on the x-axis, so that's why the radius was x. But if you rotate the function about x-axis, right, you have a many cylinder, horizontally. The radius was exactly on the y-axis. So that's why we have x and y as a radius for each different rotation. But now we are not rotating this function exactly x and y-axis. We are rotating it x minus 1. So therefore, if you are rotate on different axis or y-axis, you're gonna have a new radius. Okay, so therefore, let me just write down the formula. We're gonna keep using B equal to, so this is a similar rotating y-axis, right? Because it's vertically. So C, A and B, and we have a 2 pi. So let me just move this one. 2 pi. And then this is the formula we used to have when you rotate the function y-axis, correct? But now your radius has been shifted from x to, from x to x plus 1. So you're going to have a new radius, x plus 1. Because x minus 1, you move the, the center to the other side. So used to you have here, your center was here, but now your center is going to be here at x minus 1. So therefore, your radius is going to be x plus 1 as actually given. So that's a new radius. And then height function is going to be the given f of x equal to x. So we're going to keep the same height function, x. From where to where? From 1 to 2, correct? And then you're going to take the derivative. So this is going to be the new radius. Keep in mind, this is new radius because we rotate the function at x equal to -1, not exactly on y-axis. So one more time, this is a complicated function. This method is not really helpful because your rotation is not exactly x-axis and y-axis. Shell method is helpful because they, in the formula, they're exactly talking about the radius, and we have a new radius. So by substituting the new radius, you can find out the volume more simply. Okay, so shell method is better. That's why when you're dealing with the new radius or new height of the solid shape. So one more time, we used to have rotation on the center, but now you have a new radius because of the new rotation location. So now your cylinder is going to be at x equal to -1. That's your center. It's not the y-axis. So because of that reason, in the formula, you're going to modify, oh, new radius. And then now you are going to take the integral. So let me take the integral. Let's do it. So if you do the work equal to pi, 1 to 2, I'm going to distribute it property, x second plus x dx. And then 2 pi, we're going to take the integral, x to the third over 3, x to the second over 2, from 1 to 2. So now 2 pi, you're going to plug in 2 to the third over 3, plus 2 to the second over 2, minus 2 pi, 1 to third over 3, 1 to second over 2. You're going to subtract that. So once you do that work, you're going to get around, so oopsie. So you're going to have 2 pi, 8 over 3 plus 4 over 2, 2 pi, 1 over 3 plus 1 over 2. So calculate it. You should get around 23 pi over 3. So this is the volume when you rotate the function about x equal to -1. So in this video, we are keep talking about the shell method, but especially when you're rotating it in another vertical line or horizontal line. It's not exactly x or y rotation. Got you? All right, so we are doing awesome. So we're gonna keep practicing with this a little bit modification radius with the following example. Are you ready? Here we go, the next question. So I'm gonna keep, copying that formula, so get rid of it. So that's your shell method, and so you know. So let's read the question. So we have a region bounded by the curve y equal to x to the second, and then y equal to 4 right there. So they stop here, y equal to 4. And then x equal to 0, that's exactly the y-axis. And then that's the function. Let S be the solid generated by rotating. Okay, they're rotating the function at x equal to 4 right there. So they're not rotate the function on x-axis or y-axis. So therefore, you have a new center. This is a new center. That means you have new radius. This is going to be the radius of the circle. So what is the radius of the circle? So actually, they stop at x equal to 4 and y equal to 4. So that is going to be your radius, new radius. So the new radius is given 4 minus x. So that we're going to have a new radius. So watch me, we have, so this is actually similar to the situation where you are rotating the function at y-axis. So we're going to keep the first formula, 2 pi from a to b, x times height function dx. But now you have a new radius, which is a 4 minus x, correct? So we're going to keep it 2 pi a to b, x is now 4 minus x. And then what is the height? Height is going to be from here to here. And then we have y equal to x second power, but this is keep going, but you have to stop at 4. So the height is also changing. You stop here from here, so y equal to, this is y equal to x second, but you stop at 4. So 4 minus x to the second is a new height as well. So this is a new dx. One more time. This is the new radius. And then we have a new height function. Are you following? So let me write it. This is a new radius. This is a new height. Because this is the height, 4 minus x a second, and your new radius, 4 minus x. One thing we need to do, so, and then this is the situation, you rotate at x equal to 4. This is just rotate at y-axis. So that's a different thing as well. Okay. And do I know the interval from where to where? So we're gonna find out, the interval. So to find a comma b, right, on the x-axis. So we're gonna say x second power equal to 4. So we have a 2 function. One is here, one is there. I want to find out the intersected points. So from here, I'm looking for this is gonna be a. And we're gonna find out the b. So what are you gonna do to find out the ab? You're gonna make this 2 equation is equal to each other. So x to the second equal to 4. X is gonna be plus minus 2, but we are not gonna have the left side because this is negative. We have a right side, so it's gonna be 0 to 2. So that's your radius. So we have everything. So now I'm gonna plugging in here 0 to 2. So let's calculate it. So now we have a new radius. Now we have a new height from 0 to 2. Okay, so let's take a look at it. So we are going to work 2 pi. I'm going to take the distributive property, everything. So 16 minus 4x to the third minus 4x plus x to the third. So 16, 4 times x a second. This should be x a second, and negative 4x plus x to the third. So this is a dx. So you're going to take the integral 16x minus 4x to the third over 3, 4x a second over 2, x to the 4 over 4 from 0 to 2. So once you got this, what we're going to do? We're going to plugging in and to find out the information. And then let's calculate it a little bit. Let me minimize it. So that is going to be 25, 16 times 2, 4 times 2 to the third over 3, 4 times 2 to the second 2, 2 to the 4 over 4, and minus 0. So please calculate it. you should get around 104 pi over 3. You can use a decimal and you can change it to the decimal. So this is something that's different from the simple shell method we just practiced in the last time. Okay, so keep in mind, in this question, you have to discover, oh, do I have a new radius? Do I have a new height? Look at the given information, okay? If they're not rotating the function exactly on y-axis or x-axis, that center has been changed. That means you have a new radius of the circle. So that you have to discover them, and then you can just do the rest of work taking the integral. Okay, so this is getting better and better. I'm gonna do just a couple more examples. Are you ready, ready? So let me keep going. The second example, here we go. So I'm gonna paste this one because we keep using that formula. So this is the shell method. So we have a function, let's read it. I'm gonna just minimize it a little bit. So we have the curve y equal to x times the 4 minus x right there, and then y equal to 3. So we have two given functions. So y equal to 3 is here, and then this is the function y equal to x times the 4 minus x. Let S be the solid generated by rotating. We are rotating the function where? At x equal to 1, not x-axis or y-axis. So you are expected to see the new radius or new height. And then this is a cylinder when you rotate it at x equal to 1. So we are rotating the function at x equal to 1. So this is a similar rotating the y-axis. So we are modifying the function from here. So v equal to 2 pi a to b x times hx dx. This is exactly when you rotate it at y-axis, but we have a new radius, which is, it's a given, x minus 1. So it has been shifted x minus 1 unit to the right side. So x minus 1 is the new radius. X minus 1. How about the height? So this function is keep going down, but they stop at 3. And then this is a higher function. So you have to what? So they're going to be keep going down. So you have a many different height, but the limit is 3, right? So keep in mind, you have a maximum is a 3 minus, you're gonna subtract the original function. Okay, so that's a new height, and you're gonna take the integral. This is rotated at x equal to 1. So I'm gonna highlight it, new radius and new height. So this is new radius, this is a new height. And then we need to define what is the interval. So you're gonna set it up. This two equation is gonna be equal, correct? To find out a and b, you say x4 minus x equal to 3. So the distributive property, so x second minus 4x plus 3, that is equal to 0. So you're gonna have a 2 factor, x minus 1, x minus 3. So here x is a 1 to 3, which is 1 to 3. That's where you're rotating. Okay, that's the amount where you're rotating on the x-axis. So it's going to be 1 to 3. So now we're gonna work on 2 pi. Okay, and then 1 to 3, you're gonna expand it at x minus 1, 3 minus 4x minus x second dx, 2 pi, and then 1 to 3, x minus 1, 3 minus 4x plus x second dx. I'm not gonna finish, you're gonna finish the rest of work. Okay, you're gonna finish the rest of work, try. Because the integral part, you can try it. But I really wanna make sure that this is not gonna be x, this is not gonna be the same height function. It's a changing because you have more information. So as long as you are able to set up the new radius and new height, I think the rest of work should be okay. Okay, so let me go to the next couple questions because I want to do more complicated one. So let's go to the next one slowly and surely. I'm going to copy that because we're going to use. All right, so in this question, let's see what's going on. Compute the volume of the solid generated by revolving the region R about the y-axis. So, hey, what happened? If they are changing, they are not changing. So there's no, they're exactly rotate at y-axis. What does it mean? No new radius. Are you following? No new radius because they're exactly rotated at y. But we need to check. Maybe height could be changing. So we have a y equal to x. We have a y equal to x a second. So what happened is they're not going to go further after this intersected point, correct? So this is exactly y. So v equal to 2 pi from a to b, x times hx dx. This is exactly y-axis rotation. We know that there's no change for the radius, but let's look at the height. So when you look at this is a cylinder. They're gonna find out the volume. What happened? This is the at y equal to x and x equal to second. This is the height of the cylinder. So therefore, this is gonna be the height of your cylinder, which is x minus x to the second. This function height minus this function height, you're gonna have exactly where you're looking for the height. So therefore, height is changing only in this question. And they say exactly x is going to be 0 to 1. The interval is a given. So therefore, if you write it, 2 pi from 0 to 1, x is the same, but then height is a new. So only height is a new and 0 to 1 is a given. Only new height. Are you okay with that? That's it. So depending on the question, you have a different given information. So you have to check it out. Do I have to change both the radius and height? Or, oh, we have to change only height or only radius. So depending on the question, you need to check. So in this question, we're going to work on this. So 2 pi, I'm going to expand it, x second minus x to the third dx. You're going to take the integral now. So x to the third over 3, x to the 4 over 4 from 0 to 1. And then 2 pi, 1 over 3 minus 1 over 4 minus 0. So if you calculate it, it's going to be pi over 6. That's it. So in this question, we have no new radius, but you have a new height function. So depending on the question, in the previous question, we have a new radius and new height both. Same thing, we have a new height, new radius. So depending on the question, you have to think, okay? All right, so I'm gonna do just 2 more questions, almost done, 2 more questions. So let's take a look at the following question. Here we go. Example 4, I'm gonna copy this. Always keep in mind what you have. All right, so in this question, we have a region right there. So this is between the function f of x equal to radical x and the g of x equal to 1 over x from 1 to 4. And they're going to rotate it. They want to find out the volume of the cylindrical shape. So this is the 3-dimensional image you can imagine. But let me read it. Do they change the center? Do they change anything? So they said, find the volume when you rotate about y-axis. So what happened? So this is what? We know that no new radius, correct? Because it's going to be rotated exactly y-axis. Do we have a new height? Maybe, because this is your new height, right? This is the height. How do you know? the larger height minus the smaller height. So the height is going to be radical x minus 1 over x. This is the height function. So we have all the information, guys. So we have from 1 to 4. So let me say y b equal to 2 pi from 1 to 4. We don't have a no radius, so keep x, but then you have a new height, radical x minus x and dx. Beautiful. So you have only new height and then radius is the same. This is, oopsie, new height. Beautiful. So let's take a look at this question. I'm going to work on. So based on this equation, we can solve for the volume. So v equal to 2 pi 1 to 4. I'm going to expand it. X times the radical x minus x times the 1 over x dx. So that means 1 to 4, x times x to the 1 over 2 cancel minus 1 dx. Keep going. So 2 pi 1 to 4, x to the 3 over 2 minus 1. And then let's take the integral right there. So let me double check. Yes, we are okay. So let me go to 2 pi. And then you have x at 3 over 2 plus 1 divided by 5 over 2 minus x from 1 to 4. And then if I simplify, this is a 2 over 5, x to the 5 over 2 minus x 1 to 4. So we're going to do the f of 4 minus f of 1. So 2 pi, plugging in 4, 5 over 2 minus 4, minus 2 pi, 2 over 5, 1 to 5 over 2 minus 1. So we're going to simplify 2 pi, 2 over 5. 4 is a 2 to the second, 5 over 2. And then whatever 1 to the exponent is a 1. So you're going to get this because that is 1. And now they're cancel. 2 pi, 2 over 5, 2 to the 5th minus 4, 2 pi, and this is going to be minus 3 over 5. So 2 over 5 minus 1. So now this is going to be, I know, a little bit of work, times 32 minus 4. This is going to be negative, negative, change to positive. 6 pi over 5. So that 2 pi, if you calculate it, this is going to be 64 over 5 minus 4 plus 65 over 5. So calculate, finding the common denominator. You have everything, or you can change it to the decimal. So this is a 94 pi over 5. And you can change it to the decimal if you need. All right, we are so awesome. So it's getting better and better. So in this video, you need to see the difference from the previous video. What is the difference? You might have a new radius, you might have a new height because the rotation center is changing. Once it is a shift, you're gonna have either new radius or height or both, right? So let's take a look at the following question. Here we go. So I'm not going to solve everything. Let's set up the equation, okay? So in the equation, we have this formula, we know. So find the volume of the solid obtained by rotating the region, So we have y equal to 15x second, 15x minus 5 to the second. And then they're rotating about x equal to 6. So the radius is new. Are you okay with that? So we have a new radius because you rotate it. So we used to have, let's say, you have a cylinder at center, but now you are shifting the center x equal to 6 right there. So therefore, you have a new cylinder based on that center. So that's why the radius used to be x, but now you have a new radius, 6 minus x. This is a new radius. 6 minus x. This is a new radius. Radius is changing. Okay? So height, what do you guys think? There's no other information. Height is just keep this one. This is the height function. So now you say v equal to 2 pi, right? And then from, actually, I need to add more information. Let's say the interval is a given. Okay, let's say interval is a given. So it's 0 to 3. New radius, 6 minus x times 15x minus 5x a second dx. So this is where you rotate exactly at x equal to 6. So we have a new radius only. And then I'm not going to do it. You can finish the integral work for the remaining part. Okay, try. As long as you set up that equation, taking the integral, it's not that difficult. So check this question. You should be fine. One last one. So again, you might be confusing, or should I have to use a disk or shell method? Yeah, you can use it. So let's see, look at this one. If you don't have, if there is no new radius and height, if there's no new radius height, you can keep use both disk and shell method, right? So let's look at that. Suppose the area, so the interval, let's say I'm going to give it to you 0 to 1. This is the function. They're rotated exactly x-axis. Find the volume. So there's a no radius. We already know that in this question, it's so clear. There's a no new radius. There's a no new height because they're exactly rotated at x-axis. So according to the disk method, v equal to pi from 0 to 1. This is the function negative x second plus 1 to the second power, right? Because you have the second and dx. This is a disk method. And then you're going to have a shell method, v equal to 2 pi from 0 to 1. There's no new radius and height. They're exactly rotated x, so it's the opposite y. And then the function is, but we have to be careful. This is the in terms of the x variable. So f of x equal to negative x second plus 1. I want to convert it to the f of y. So that you're going to solve for y. So y equal to, we're going to solve for x, my bad. So do you remember? I'm going to just make a space here. Here in the shell method, this is the shell method. If you rotated x-axis, everything should be in terms of the y variable. So we have to convert this x function in terms of the y variable. So that's what I'm doing. So y equal to negative x second plus 1. Let's solve for x. So that y minus 1, negative x second. I'm going to put the radical on both of sides. So it's going to be, actually, before we're going to do that, let's divide it by negative everywhere. So negative y plus 1, positive x second. Now you're going to put the radical. So negative y plus 1 equal to x. This is your f of y equal to radical negative y plus 1. So that's your new, this is not new height. This is the same height in terms of the y variable. Negative y, or you can say 1 minus y. Same thing, change the order. So I just want to mention that, okay, this one, right? And then this is going to be dy. This is not new height. This is just f of y, height, h of y or f of y, doesn't matter. This is the height in terms of the, with respect to y variable. That's it. Because according to the formula, according to this formula, if you rotate about x-axis, whatever the function should be in terms of y. So this is not new height, just the h of y with respect to y variable. That's it. So once you calculate these two integral, you will get the same answer. Check it out. They're going to give you anyway same. One is you can solve this one by disk method or shell method if there's no new radius or no new height. Make sense? So if you have a new height or a new radius, you have to use a shell method. So this is a so good question. You can check it out. So let me just summarize what we just talked about it. Okay, so to find out the volume, you have a couple: slicing method, disk method, washer method, and shell method. Disk and shell, they have many commonality. Washer, you need a two function, so it's not common thing, two functions. So disk method, you can use it if there is no new radius, no new height only, right? Because the cross-sectional image give you the same radius, give you the same height. But if you have new radius or new height, that means your radius is changing based on the x variable, your height is changing based on the y variable. So then shell method is going to be very, very useful. So you can use both if there's no new radius or new height, but if there is, shell is always the way. Okay, so check it out. Those are four, different methods. There's a lot of commonality and differences. You need to check it out. And that's it, pretty much 2.3, we finished. Okay, so in this video, I try to emphasize on the commonality and differences among different methods. So make sure each example that I show you will be a great practice for you to understand the better concept. Okay, so I will stop here. So that's we finish entire 2.3. We see all the original traditional shell method plus why this is a benefit, because it helps us to find out the volume when you have a new radius and height. This method cannot do that, right? So that's why we just observe the benefit of using the shell method in this video. So I will stop recording at this moment so you can complete entire 2.3 quiz. And then if you have any question, always participate in discussion board, engage with other people, and feel free to email me if you have any questions. I will see you soon in the next video. Thank you, everyone. Bye-bye.